Okay, you're welcome to the class for today. We want to use equations of motion. What is the first equation of motion?
First equation of motion is V equals to U plus AT.
Yeah, that's correct. Equation 1, that is V equal to U plus AT. What, what is V? What is U? What is A? What is T?
Sir,
Yes,
V is final. U is initial velocity. A is acceleration, and T is time.
and T is time. That's correct. That is coming out in your test and exam. Coming out in your test and exam. So, if we rearrange the equation, how can we find U? We can say V minus AT equal to U. Okay?
Yes, sir.
If we rearrange the equation, how can we find A? A equal to V minus U over T. And this is the formula for what?
Acceleration.
Acceleration. That's correct. Then, if we rearrange the equation, how can we find T?
Find V minus U over A.
So take note of these four cases. You will need them in your test and exams, okay? For example,
Okay, sir.
for example, an object accelerates from 10 meters per second square velocity, from 10 meters per second velocity rather, at 2 meters per second square acceleration for 5 seconds. Find its final velocity. Find its what?
Final velocity.
Don't write anything. Close your book. I will give you time to write. This is final velocity in the first equation here. Final velocity is initial velocity plus acceleration times time. So final velocity will be initial velocity plus acceleration times time. It is clear.
Yes, sir.
The final velocity is 10 plus 2 times 5. So final velocity will be what? 10 plus 10. That will be
Final
what?
velocity 20. 20
If you do your work and you did not put unit, you miss your answer. 20 meters per second. Okay, that is for the first case. What about U? If I want to find U separately, hold on. An object attained a final velocity of 15 meters per second after accelerating at 3 meters per second square for 8 seconds. Find its initial velocity. Find its what? Find its what?
Initial velocity.
Don't write yet, just look at the board.
Initial velocity.
So we have u equal to v minus at. So u equal to final velocity 15 minus acceleration 3 times the time taken. Right here. This is kind of going to give me negative. Let me adjust the parameters. Don't write yet. Let's say this is 0.8 seconds, okay? Is that clear? Is that clear? So, what I'm going to have is u equal to 15 minus 3 times 8 over 10. U equal to 15 minus, what is 3 times 8? 24 over 10. U equal to 15 minus 2.4. And that'll be what?
That would be 12.6.
So I said 15.0 minus 2.4. This is 6, this is 2, and this is 1. 12.6. So that is 12.6 meters per second, okay? Is that clear? Is that clear? Can you hear me?
Yes, sir.
Yes, sir.
Okay, now the third
Yes, sir.
scenario. Let's say
What happened?
So when we go to like then, how was I shouting? That is the reason that you're shouting.
your noise is too much. Can you hear me now?
Yes, sir.
At what acceleration at what acceleration must an object or like a car be moving to have attained a velocity of 20 meters per second in 5 seconds? From rest. Read this question, both of you.
We should solve it.
Read the question, both of you.
At what
At what acceleration
acceleration
must an object be moving to have attained a velocity of 20 meters per second in 5 seconds from rest?
Okay, so acceleration is v minus u over t. What is v? What is u?
V is 20.
What is the
U
time?
is 0.
Now, how did I know that
The
u
time
was
is
0?
5.
Okay, Key. How do I know that u is 0? Okay, Key. Okay, Key.
Sir?
How do I know that u is 0?
How did you know that U is 0?
How? Was it mentioned in the question? Kingsley, how do we know that u is 0?
Because it is from rest. And
Because it is from
initial
rest. That's all. That's all. That's all. It's from rest, okay? Any object at rest is not moving, okay?
Yes, sir.
So therefore, any object not moving has velocity of 0. So then from rest, it accelerates until it gets to 20 meters per second in 5 seconds. So what is 20 minus 0? Then divided by 5. What is 20 divided by 5?
4
So what's the acceleration? 4 meters per second square, okay? Is that clear?
Yes, sir.
Now let's see the last scenario there, number 4.
Just consider it.
After, okay, or let's say, how long will it take a car accelerating at 0.5 meters per second square to reach a velocity of 60 meters per second from an initial velocity of 45 meters per second. Read the question, both of you.
How long will it take a car accelerating
Accelerating at
at
0.5
0.5
meter per second square to reach a velocity of 60 meter per second from an initial velocity of 45 meter per second.
So what are we looking for?
We're looking for time.
Time. And time is what?
Time is t.
No. Time is what?
V minus u over.
So what is V? What is U?
V is 60, u is 45, and a is 0.5.
So what is 60 minus 45?
15.
Okay. So the answer is what?
The answer is 30
30 what?
seconds.
30 seconds. Okay, now write down the first page. When you finish, you let me know. We'll go to the next page. All right. We're going to continue shortly. By asking a question, please ask your question again.
how do you know that it's 10 and the how do you know that it's 2?
Okay. Now look
So
at
how do you know
this.
it's 5?
If you look at this, it says an object accelerates from somewhere. Okay. So initial velocity is where the object starts accelerating from, okay? So once you see a velocity and you see the word from, accelerate from that velocity, then that velocity must be initial velocity, okay? Okay?
Again, I don't hear.
Yeah. I say once you see velocity, this is velocity, right?
Yes, sir.
How do you know its velocity? You know the unit of velocity is meter per seconds, right?
Okay.
So what you need to know is that velocity, whether final or initial, is meter per seconds. So once you see meter per seconds, you will know whether it's going to be final velocity or initial velocity. Since you are looking for final velocity, then this must be initial velocity. Okay?
Okay, sir.
Uh-huh. Another way to know is that when it said it started from that velocity, the velocity the object starts from is the initial velocity, while the velocity the object will reach at a later time must be the final velocity. Is that clear? Good. Then, how do you know that 2 is acceleration? An object must accelerate at an acceleration, okay?
Okay.
When you see traveling at and you see meter per seconds, that is velocity, which might be initial or final, depending on what you're looking for. But when you see meter per second square, it must definitely be acceleration. Is that clear?
Acceleration. Yes, sir.
So acceleration is always what? Meter per second square.
Meter per second.
Velocity is always what? Meter per seconds. So whenever you see meter per second square, know it's definitely acceleration. Whenever you see only seconds, know it is time, okay? And whenever you see meter per seconds, it could be U or V. So depending on what it says, if this is the velocity where it's starting from, then it is U. If it is this velocity is going to reach, then it is V, okay? So are you through with the first page now?
Yes,
Yes,
sir.
sir.
Okay, you can put down the second page. So like this page now, it says an object attained a velocity. If you don't put final, it is still final velocity. Once you say it reaches that velocity, then you must know it's a final velocity. So an object attained a final velocity of blah blah blah, whatever it is, after accelerating at, you can see this is
An object what?
attained.
Attained.
That is, an object reaches a final velocity, okay, of this. So this is the final velocity. Then you are looking for the initial velocity because that is what they say you should find there. Then the time is 0.8 in seconds, while the acceleration is 3 meters per second square. All right. Number 3.
Also, what I wanted to ask was that how do we get 4 meter per second square? Like that meter per second square. That's
Okay. The main thing you need to know is that what are you looking for?
acceleration.
Acceleration. And acceleration must be in what?
meter per second square.
So whatever you get, put it as meter per second square. Or you can say this is meter per seconds, also seconds, okay? So seconds times seconds is what? Second square.
Square.
Is that clear? Do you understand?
Yes, sir.
Okay. But in case of confusion, you just need to know the unit of what you're looking for, then you apply it there straight away. For example, if you are looking for force, look here, you are looking for force. You know that force is mass times what? Acceleration, right?
Yes, sir.
Which is F equals to ma. Mass is in kilogram. Acceleration is in meter per second square. So you will not put this as your unit of force. Force is always in Newton. So whatever you get, you put Newton, not this, okay?
Okay, sir.
Is that clear?
Okay, sir.
So you don't have to always say you want to get the unit from your formula. No. Just know the unit of what you're looking for. Now you can write the last page. The second equation of motion is what?
If S equals to UT plus 1 over 2 plus AT square.
S S equal to UT plus half AT square. What did I say? S equal to UT plus half AT square. Okay. That is the way to pronounce it, okay?
How will you help us in
S equals to U T plus half T
Half AT square.
together.
Half AT square. You know, that is the pronunciation, okay?
Yes, sir.
That is the way to pronounce it. S equal to UT plus half AT square. So you know that this is S, this is equal, this is UT, then half AT square.
Yes, sir.
Okay, so if we rearrange this formula, we can rearrange it to find U. How can we do that? We can say S minus half AT square equals to UT. Then we can divide both sides by T, okay?
Bible said by T.
So this over T, and this over T. T cancel T. So U now, we can say equal to S over T minus half AT. There's no square again because this square and this will cancel. You know, T square is T times T square is T times T, right?
Yes, sir.
So 1T will be cancelled by this one. It will now remain only 1T. And we can say we want to rearrange to find A. So to rearrange it to find A, we can say S minus UT equal to half AT square. So 2S minus 2ut equal to at squared. If you multiply both sides by 2, 2 will cancel this one. Then you have to divide this by t squared. So you have a equals to 2s minus 2ut all over t squared. So you can also use it. What did you say?
How did you get 2s?
2s. Very good. Let me explain. You know, this is s minus ut equal to at squared over 2. Yes or no?
Yes, sir.
You know that is half at squared. So you now multiply both sides by 2. This side
By 2.
times 2 and this side times 2. 2 cancel 2. And you have at squared equal to 2 times s, 2s. 2 times ut,
By 2s.
2ut.
2.
Then you can now divide both sides by what?
That goes like a.
T squared, since you are finding a.
Okay, get that.
So t squared will cancel t squared. Acceleration is now 2s minus 2ut over t squared. Now, how can we rearrange it to find our t? That is going to require another strategy, because there is an exponential t there, which is a square. So to find t from s equals to ut plus half at squared, we will need to factorize it. So we can say half at squared, or we multiply everything by 2 first, okay?
Okay.
So we have 2s equals to 2ut plus 8 squared, because when you multiply by 2, this one will go away, okay?
Yes.
Then you now have 8t squared plus 2ut minus 2s equal to 0. So you will need quadratic formula for this. Ax squared plus bx plus c equal to 0. Then x must be what? Minus b plus or minus what? Square root of b squared minus 4ac over 2a. So you are going to use that to find your t. So t equal to minus b. What's our b? That's 2u, okay? Plus or minus what? Square root of 2u squared minus 4 times a, which is still a, okay? Then times minus 2s all over 2a. So this will be the formula if you ever need to find all of this from that formula. You can write them down, write everything down, okay?
Okay, sir.
Then we'll continue. Right.
Write this for try this place.
I'm going to take this question to the board. You will try the question a bit before I now. Oh, wait. Because of our time, I think I'm just going to look at it with you. Okay. So let's see. I'm taking it to the board now. Can you see the question?
Yes, sir.
Read it for me. Let me hear.
The boat traveled 12.0 miles while it reduced its velocity from 9.5 meters per second to 5.0 5.5
meter per second. What is the magnitude of
magnitude of the boat's acceleration while the traveling is 12 miles.
Now, Okiki, I want to direct this question to you. I will write three formulas. V equal to U plus AT, S equal to UT plus half AT square, then V square equal to U square plus 2AS. Which of the three formulas do you think we should use and why, Okiki? Okiki, can you hear me?
Yes, sir.
Which of the three formulas do you think we should use and why?
We're looking, what is the magnitude? We're looking for the magnitude
Magnitude of what?
of the boat acceleration.
What are we looking for?
The acceleration.
The acceleration. So what are the things we were given?
So we were given 120 meter.
What does 120 meters stand for?
No,
That is the displacement. That is the what?
displacement.
Then what else are we given?
Size 12.0.
Okay, 12.0. What else were we given?
9.5 meter per second.
9.5 meter per second is what?
Meter per second.
That stands for what?
Velocity or initial velocity.
Which one?
Velocity. Okay, that means we're looking for the initial velocity.
What does 9.8 stand for? 9.5, what does it stand for?
Initial velocity.
Initial velocity U. 9.8. What about 5.5? What does it stand for?
Velocity.
What type of velocity?
It's the initial velocity.
Are you sure?
Sir?
Are you sure?
No, it's velocity.
It is final velocity, okay? Now look at it. Initial velocity is bigger than final velocity. What can you say about the acceleration?
The acceleration is negative.
What did you say, Kingsley?
The acceleration is negative.
It is negative. The acceleration is negative. Is that clear?
Yes.
That means it is not increasing its speed, it is reducing its speed, okay? From 9.8 to what?
To 5.5.
I mean from 9.5 to 5.5, good. So now, which of the three formulas above do you think contains all the things we were given? The first formula required time. The second formula required time. Is there time in the question?
No.
So we're using the third formula.
So we're using the third formula. V square equals to what? U square plus 2AS. And we're looking for the acceleration, right?
Yes, we're going to make A the subject of formula.
So that means V square minus U square. But then, because we observe that it's decelerating, so that will be negative, okay?
Yes, sir.
Then we can now say 2as, if we take it out, equal to u square minus v square. Then a equals to u square minus v square over 2s.
Over AS.
Over 2s.
And 2S.
So, are you getting it?
Yes, sir.
Then we have acceleration equals to, what is u?
U is 9.5.
No. Okay, yes, that's correct. What is v?
V is 5.5.
Square. Then over what?
12.
S is 12.
2 times 12. So what is 9.5 square?
That is 450.
What did you say?
Okay, 9.4.
90.25.
90.25.
Yes.
What about 5.5 square?
30.25.
30.25, right?
Yes, sir.
30.25. Then over what? 24.
Over 24.
So A will be 90.25 minus 30.25.
That is 60.
Divided by 24. That will be 2.5. 2.5 meter per second square, okay? Is that clear?
Yes, sir.
And this is the correct option. Now write down the question and write down the solution. Then we end the class for today.
So no assignment.
Yeah, just prepare for your test. You're going to have test on Friday by God's grace, like I said. 9 a.m. Alright, viewers, thanks so much for watching. Subscribe to this channel. Okay, goodbye for now.